this section we'll be discussing what it means to have like terms. Before we do that, let's talk about what terms are. Terms are parts of an algebraic expression that have factors that are being multiplied. Sometimes you might have more than one variable, maybe being raised to a power. But the easiest way to recognize terms is they're always separated by pluses or minuses. So if I look at this example at the top of my page, I have 1, 2, 3, 4, 5 terms because I have 5 items that have pluses or minuses between them. So that's my 5 terms. Like terms have the same variables raised to the same exponents. Okay? So in this example, 2x and 8x and negative 3x, those are like terms because they all have an x to the first power as part of that term. If they don't have a variable, we call it a constant. So 7 and 5, these are called constants because they don't have a variable. Now I have also set up this using algebra tile, so I'll show you what I did. I've modeled this exact expression that you see at the top of your paper using algebra tiles. So the 2x plus 7, there's my 8x's, and there's my 5, and then my minus 3x, I'm just doing negatives for my x's. So this is negative 3x, where the red just represents negative x. We're going to use the distributive property to learn how to combine like terms. However, the tiles, you can use those as well to do the same thing until you understand what's going on with it. So we know from the commutative property that we can move the order around any way we want to. And I know that if I take a positive 1x and a negative 1x, just like happened with the integers, positive x and a negative x, you put them together, they make 0x. Well, 0x is still 0, so that one just goes away. You don't even need to look at it anymore. Here, positive 1x, negative 1x, added together, that makes another 0. And then here is another 0x. That's 0x. So all of these you can just completely disregard, and you can rearrange what you currently have, and you are left with, how much is this? Alright, so we've got these and we've got these together. So this is going to be our simplified version for our answer. So we've got 7x and we've got 12. 7x plus 12 is the simplified version of that same expression. Alright, now let's look at the rest of the page. Okay, so an algebraic expression is in simplest form if it has no like terms and no parentheses. And we just showed what simplest form would look like using the tiles. Let's look at example 1. It says to identify the like terms in each expression. Okay, so part A, I have 9x minus 2 plus 7 minus x. The like terms are going to be the ones that have the x's attached to them. So 9x and negative 1x, those would be my like terms. So I'm going to put 9x, oops, I'm sorry, those are the like terms. I'm answering the wrong question. So my like terms are the 9x and the negative 1x. When it says terms, it's asking me for all of the things that I see that are separated by plus or minus. So the 9x, the negative 2, the 7, and the negative x, they're all considered terms. The like terms are the 9x and the negative x. In part B, 6 plus 5z minus 3z plus z. So the terms are all the things that are separated by plus or minus. So 6, 5z, negative 3z, positive z. The like terms would be the ones that have the z attached to them. So the 5z, the negative 3z, and just 1z. Those are my like terms. Again, the constants are the ones that don't have z's at all, or don't have variables. Example 2, we're going to simplify by combining like terms. Alright, so I'm going to show you how you'll be doing this algebraically. If you need to see it using tiles as well, or draw a picture, go for it. That's great. All right, so what we're going to do is we're going to first identify our like terms. We've got 4x here. We've got negative 2x here. I know from the commutative property that I can rearrange these. So I can write this as 4x, and I can think of this as plus negative 2x. So if you want to write it back here, that's fine. Plus negative 2x plus 6 plus 3. And then if I just look at the 4x plus negative 2x, this is where the distributive property is coming into play. The way this works when you combine like terms is you're going to add the coefficients, the numbers in front of the variable, and then you're still going to multiply by x, but you're going to do 4 plus negative 2, and then you're going to still bring these numbers down, of course, don't lose those, but 4 plus negative 2 gives me positive 2, so when I combine these two, I end up with 2x, and then 6 and 3 gives me 9. So 2x plus 9 is my simplified answer. So this is how we combine like terms. Example 3. Same idea. They threw some fractions in here, but that's okay. We should be able to handle this. 3/4 y plus 12 minus 1/2 y minus 6. You may find it helpful to, every time you see minus, you might want to say plus and then make it negative of whatever follows it. Minus 6, you can say plus negative 6. That way, the commutative property does apply as long as everything is addition. If you've got subtraction in there, then you would have to be super careful about rearranging your terms. But if you write it as plus negative, then you can start moving things around as needed. Okay, so we got to first find our like terms. 3/4 y, negative 1/2 y. Those are my like terms. So I'm going to write this as 3/4 y plus negative 1/2 y plus 12 plus negative 6. I'm throwing these parentheses in so I understand that these are negatives and not subtraction. Now I can do the distributive property to combine the 3/4 and the negative 1/2. So I'm going to say 3/4 plus negative 1/2 times y. Just bring the rest of it down for now. But I have to do 3/4 plus negative 1/2, so I can come off to the side and do my scratch work. 3/4 plus negative 1/2. We've had lots of practice with this. I need I need a common denominator. So common denominator is going to be 4. I need to multiply this one by 2 over 2. So it's 3/4 plus negative 2/4. Adding these together gives me positive 1/4. So this is 1/4 y. And then 12 is going to be plus, and 12 plus negative 6 is going to be positive 6. So 1/4 y plus 6 is my answer. Alright, so I don't really know how you could use algebra tiles to model the ones with the fractions. I mean, I do, but it would be kind of weird trying to do it. But at any rate, that's the way the distributive property works for combining like terms. This is how we combine like terms. This is super important for later when you get into real algebra. You've got to know how to do this, so it's important for us to spend time on. Okay, and then the practice page. Identify the terms and like terms in the expression. Okay, so I'm going to let you do these on your own. Get the algebra tiles if you need them, or draw the pictures, and then check your answers with me. And here are your answers. Number 1 is negative 1/2 y plus 10. 2 is 8r minus 9. 3 is 5p plus 2q plus 2. This one you can model using the tiles. You would just want to use a different color for your second variable because you have 2 different variables here. Number 4, 6.8x minus 5. Number 5 was negative 3/8b. And 6 was negative 2z plus 22. You might want to, maybe when you draw your z's, put a little line through them so that they don't look like 2's, because they could really all kind of run together there. Alright, but these are your answers, and there is an assignment that you should be able to get from your sub for additional practice on these. Again, you don't have homework, but you need to be working on these as much as you can during class.